Hey everybody, I just wanted to give you a more visual representation of balanced and unbalanced forces by using this simulator. Depending on whatever option you're going to pick for distance learning this week, you'll still get a chance to play around with this, but I wanted to show you what I'm talking about. I'm going to start off by talking about what a force is. Force is probably the simplest definition you will ever come across in science. It's a push or a pull. So if anything is pushing or pulling on you, you've got a force being applied to you. I'm going to start by adding two little guys to either side, and I want you to notice a couple of things. Number one, blue man is pulling with a leftward force of 50 newtons. Newton is the unit of force that we use. And then red man here is pulling on the right, also with 50 newtons. So if we hit the go, we will notice that there's zero speed and there's no motion going on here. So this is an example of a balanced force, equal and opposite forces. This results in no change in motion. This would mean no change in speed, no change in direction. In other words, there is no change in velocity, and therefore there is no acceleration going on. That is a balanced force. Now, if we add, let's put middle blue guy up here. Now we have a combined force on the left of 150 newtons, 50 plus 100. And then he's still pulling with 50 newtons on the right. And as you probably guessed, blue team is going to win this round. It's because we have an unbalanced force being applied to the cart. An unbalanced force will always result in a change in motion. And we're talking about unbalanced forces because that is the concept behind Newton's first law of motion. No change in motion can take place without an unbalanced force. That's the way I like to summarize Newton's first law. There's other ways to say it, but I like to say that no change in motion takes place without an unbalanced force. So we have an unbalanced force, and then there's one other thing I want to show you. So if we take these guys down, and if we add another guy here, the forces add up. They're pulling in the same direction, so we add the forces, and then we end up with the sum of forces of 100 newtons. We also call the sum of forces the net force, which if you looked at your Quizlet deck, you will probably see net force in there. However, if I add big red man over here, he's pulling with a force of 150 newtons. They're pulling with 100. The sum is now 50. So when we have opposite forces, we subtract them to get the sum of the forces or the net force. And of course, red man's going to win because he is pulling to the right with more force. This is an unbalanced force, and therefore there's a change in motion. So I hope that helps. Again, if you have any questions, don't forget to email me, post on Google Classroom, or request a Google Meet if you need to talk to me face to face. Thanks for listening. Bye.